You ever wonder if there's a single hidden blueprint for everything? Today, we're diving into a really mind-bending new framework that tries to do just that, to stitch together the very fabric of our universe, from the tiniest quantum weirdness all the way up to the cosmos.
So let's just start with a massive question. What if the fundamental rules that guide a tiny little quantum particle are the exact same rules that organize a living cell and maybe even shape our own conscious experience?
Yeah, that wild idea is pretty much the core premise of the theory we're looking at. It's a bold, and I mean really bold, attempt to find a single common language that connects these worlds we usually keep separate: physics, biology, and even consciousness.
So, here's the big idea. At the most fundamental level, reality isn't made of matter or energy. It's made of information. And the rules that organize this information, they don't care about size. The theory suggests the same basic pattern, the same kind of natural algorithm, is at work in an atom, a strand of DNA, and a whole galaxy.
Okay, to really wrap our heads around this, we have to start with the theory's two fundamental building blocks. And they have some, well, let's call them unusual names: divots and optimal correlation. Let's break down what these actually mean.
All right, first up, a divot. Think of it as a little point of stability in an otherwise chaotic world. Imagine a vast, bumpy energy landscape. A divot is just a small dip in that landscape, a place where things can settle down and create a tiny island of order. It's like a stable little pocket of structure in a sea of randomness. Now, this is where it gets really interesting. The theory says these divots don't just sit there. They organize themselves into these incredible branching, fractal shapes, just like you see in a lightning strike. These patterns, known as Lichtenberg figures, might not just be a cool visual. They could literally be nature's fundamental algorithm for creating complexity. The second key idea is optimal correlation. Think of this as the ultimate sweet spot for any system. It's not totally wild, unpredictable chaos, but it's also not some rigid, frozen, boring order. It's that perfect state of balance right in the middle, where a system can be both stable and flexible enough to change and adapt.
And incredibly, this isn't just some vague philosophical idea. The theory actually puts a number on this sweet spot. It identifies a value of about 0.5, you see it here with the Greek letter rho, as the magical point where systems, whether they're quantum particles or biological networks, just naturally click into their most stable and coherent state.
Okay, so we've got the core concepts. But talk is cheap, right? Where's the proof? This is where things get really compelling, because we're about to see the exact same patterns show up in two wildly different places: a quantum computer simulation and actual living cells. Okay, take a look at this. On the left, we've got a computer simulation of 100 quantum particles. When they're allowed to evolve following this optimal correlation rule, they spontaneously arrange themselves into 6 stable clusters. Now look over to the right. Those are mitochondria, the little power plants inside our own cells. And guess how they organize themselves? Into networks of, yup, you guessed it, about 6 clusters. It's the same pattern, separated by a mind-boggling gap in scale.
And this isn't just us squinting and saying, hey, that looks kind of similar. The hard data backs it up. The simulation showed a whopping 73% improvement in organization once it hit that sweet spot. The number of clusters wasn't random. It was 6, a direct match for what we see in biology. This suggests there's a deep mathematical connection between the quantum world and the world of life.
All right, deep breath. We're about to take this one giant step further, all the way up to consciousness itself. In what might be its most ambitious leap, the theory actually tries to create an equation for the mind, modeling our inner world with the same kind of math you'd use for physics.
It does this with something called a composite wave function. The idea here is that our consciousness isn't just one single thing, but a combination of 3 interconnected fields. You've got the psychological field for our thoughts, the emotional field for our feelings, and of course the biological field for the physical brain and body that runs the whole show.
And this flowchart here gives you a sense of how it all connects. The order within our own minds and bodies generates information that feeds back into the system. But here's the kicker. It's not a closed loop. The theory suggests this whole system is connected to a bigger, cosmic coherence. In other words, our individual consciousness might just be one small node in a vast, universal network.
And the implication of that is massive. This is a direct shot at what philosophers call the hard problem of consciousness. It's saying that your subjective experience, what it actually feels like to be you,
isn't some mysterious ghost floating around in the machine. It is the physical process itself. It's the real-time, dynamic hum of this incredibly complex information.
Okay, now for the final and maybe the most surprising piece of this puzzle. This is where the framework connects two worlds that you'd think are complete opposites: ancient spiritual wisdom and the cutting-edge future of artificial intelligence. In a truly fascinating move, the framework reinterprets the ancient Hindu text, the Bhagavad Gita, but through the lens of modern physics. It suggests that ideas about ethics aren't just human inventions. Divine, or good actions, are the ones that create stability and lower disorder, what a physicist would call low entropy. And demonic, or bad actions, they do the opposite, creating chaos and instability. In this view, morality isn't just philosophy, it's a law of thermodynamics.
And this isn't just some abstract thought experiment. It could give us a blueprint for building better AI. Imagine training an AI not just to chase a reward, but to actually value stability and resist getting thrown off by noise. Or think about an AI that could shift gears, using a stable, divine mode for precise tasks, then switching to a chaotic, demonic mode for creative brainstorming. This could be a totally new way to think about AI safety. So, if the same principles are organizing quantum fields, living cells, our own consciousness, and maybe even our ethical systems, it leaves us with a pretty profound final thought. If our biology is already wired into this cosmic information network, what else might it be capable of that we haven't even begun to imagine?